Welcome to this eLearn Security training video on OS Fingerprinting. Knowing what OS is running on the target machine is very important for a penetration tester because it allows for more precise decisions on what type of vulnerabilities or attacks may be used during the process. We will begin using a very popular tool called Nmap. Nmap is a network mapper and has many functionalities, including OS fingerprinting. The Nmap OS Fingerprinting works by comparing UDP and TCP packets sent by the target to fingerprints in the Nmap fingerprint database. Since OS has different TCP stacks, they respond with different packets and different flags. It is possible for Nmap to make educated guesses and inferences about what operating system is running. Nmap can run on both Windows and Unix OS. On Kali Linux, Nmap is already installed, so we do not need to download or compile it. Let's see how to run Nmap. We can do it by opening a new terminal and typing Nmap. As we can see, the tool is already installed, so the help manual is printed out. In the output, we can see that Nmap has a lot of options we can use depending on the purpose of our scan. For example, we have options to specify a single target or a set of targets. We have options to perform host discovery and many different scan techniques. For our purposes, we are interested in OS fingerprinting, so let's scroll down a bit to verify which options we can use for the OS detection. Here we can see that the option to use is -O. But we can also configure a more accurate scan by selecting one of the previous scan techniques. In our case, we will use the -S option that allows us to perform a TCP connect scan. So let's start writing our command in the terminal. First of all, let's write Nmap, followed by the scan technique, which is -S. Then, the -O to instruct Nmap, we want to run an OS detection and, at the end of the range, IP addresses to scan, which in our case is 192.168.102.0/24. As soon as we hit enter, the scan begins. Since it is going to scan the whole network, it may take a while. During this process, we can see the current status of the scan by pressing the up arrow key on our keyboard. Here indeed we see how much time has elapsed, how many hosts have been found, what operation is running, and also how much time is left to complete the whole process. So let's wait a bit until it finishes the scan and prints out the results. Here we are. From this output, we can see a list of machines running on the network and some other information. For example, here we can see that we have the machine at the address 192.168.102.2 with the TCP port 53 open. If we continue to inspect the output here, we have another machine running on 192.168.102.135. This one has a few more open ports, and below we can see what operating system Nmap identified on the target machine, which in this case seems to be a Microsoft Windows XP. A few more details can be found right after, and indeed, we can see the Nmap best guess for this machine is Windows XP, SP2 or SP3. Let's continue to inspect the results. The machine at the address 192.168.102.138 has many open ports, and Nmap identifies the machine as a Windows Server 2003 SP1 or SP2. Sometimes the scan may also fail. Here indeed, we can see that Nmap was not able to correctly identify the OS of the following machine. This may happen if a firewall blocks or rejects some packets, altering the normal behavior and the fingerprint of the responses. Till now, we have found 2 Microsoft Windows machines, but Nmap works for other OSs too. Indeed, at the address 192.168.102.220, we can see that Nmap identified a machine that may have one of the following operating systems. Note that there is a warning in for this host. This warning indicates the scan results may not be 100% correct. It was not able to find at least one open and one closed port on the target machine. Anyway, Nmap provides its best guess based on the results of a Kamau embedded FreeBSD 8.1 or an OpenBSD 4.x machine. Since our machine is in the same network of the target machines, Nmap also scanned our IP address and found that we are running a Linux 3.x OS. So let's verify if the Nmap results are correct. We can start checking the OS of our machine. To do this, let's run the following command in the terminal: uname -a. As we can see, the Nmap guess is correct. Indeed, we are running a Linux machine 3.14, which is close to the range defined in the output. Let's now verify the OS of the other machines. Let's check the machine at the address 192.168.102.135. If the Nmap guess is correct, it should be a Windows XP. First, let's verify that the machine is the right one by checking its IP address. So let's open a command prompt and type ipconfig. Alright, now we are sure that we are here in the 0.135 machine. Let's verify the OS by opening the computer properties. Great, the machine is a Windows XP SP3, so Nmap has correctly identified the OS. Let's go on and verify the OS of the machine 192.168.102.138, which should be a Windows Server 2003. Once again, let's be sure we are on the right machine by printing the IP address. It is correct, so let's check the OS in the same way we did for the Windows XP machine. And again, it seems that the Nmap guess is correct. The last machine we want to check is the FreeBSD machine at the address 192.168.102.220. So let's switch into our machine and check the IP address as usual. We are in the right machine. Let's run uname -r and check the OS. As we can see, Nmap was very successful on identifying the remote operating system on the target machine. And this was a simple example of how Nmap can be used for OS fingerprinting. This concludes this video training lesson on Nmap. Thanks very much for joining us.